Okay, you have space on page 751. Is that right? Is that a blank page? Yeah. Okay, let's do example 4 here. Another type of question that sometimes comes up on the exam are questions that say, find the term containing, and then here we'll do x to the 9 in the expansion of So if you expanded this and simplified it, there would be 10 terms. One of those terms has an x to the 9 in it. We don't know which one. So one way, the long way to go about this, is to find all 10 of them, simplify all 10 of them, and then once you find out which one has the x to the 9, then you can write that as your answer. Okay, we're going to look at a pattern way to find out which term has it, so we don't have to go through all of that. Okay? Now, using our formula, we don't know what term it is. We don't know what k is. So for right now, we're going to leave k out of it. Term k plus 1, we do know that n is 9. It's going to be 9 choose k. Our a is 3x squared, and this will be 9 minus k. And then negative 2 over x to the k. This is setting up the formula with what we know, but we don't know what k is yet. What we do know is there's going to be some number, and once it's simplified, it's going to be an x to the 9. So for right now, all we know is the exponent of x, that it has to be an x to the 9. So we can sort of temporarily ignore everything that's going to affect the number in front, because we're going to find out what k is first. Can you see that this 9 choose k is going to be a number? We're going to temporarily just ignore that. Same thing with this 3. That's going to affect the number in front. We're going to ignore that. And we're also going to ignore this negative 2. We're just going to look at the x's. If we just looked at the x's, what do we have? We have an x squared right here. That's to the power of 9 minus k. And we have an x on the bottom that's going to be to the power of k. Let's try some values of k. Pick a number for k. 9. If we tried k to be 9, well, this will be 0, right? And then you would get an x to the 0 on the top. And you would have an x to the 9 on the bottom. But that doesn't give us, that gives us an x to the minus 9. And we're looking for an x to the positive 9. So starting with k equals 9, some of the things that, patterns that I want you to see is when you have an x squared over an x, right, we're going to need more numbers on the top, more x's on the top than on the bottom. So we're going to have to figure out a k value from that. Okay? So let's try a different value of k. So this is when k was equal to 9, and it didn't work. Someone said try k equals 3. What is 9 minus 3 going to be? That's going to be 6. That's going to give us x to the 12 on the top. And if k is 3, that's going to give us x to the 3 on the bottom. When this simplifies, we get x to the 9. So we just figured out that k has to be 3. Now it said find the term containing that, so now we have to find term 4. Because we figured out k has to be 3, it's going to be 9 choose 3. 3x squared to the 9 minus 3 will be 6. And negative 2 over x to the 3. Nine choose 3 is 84. Expand each of these separately, because if you try to do too much at once, you'll make a mistake. 3 to the power 6, 729. X squared to the power 6 will be x to the 12. Negative 2 cubed will be negative 8. And x cubed. Multiply our numbers together, so 84 times 729 times negative 8. And our x to the 12 and x to the 3 simplify to give us just x to the 9. So there's the term containing x to the 9 in the expansion. Happens to be the 4th term. We're going to do one more example like this. Find the constant term in the expansion of 5x cubed minus 2 over x to the power 12. So here's the definition from algebra. I think you first learned this definition in grade 9. What does it mean to be a constant term? A term that has no variables. So that would be just a number. It has no variables. Or another way to think of it, in order to have no variables, it would have an x to the 0. So that's sort of how we're going to use our pattern thing to help us find it. So I want some number and then no x's. So all of our x's are going to have to cancel out. Now if we look at tk, that's some term. We don't know what k is yet. We know that our n is 12. We're choosing k. Our first term is 5x cubed, 12 minus k. Our second term is negative 2 over x to the k. You have to come up with a value of k so that our x cubed, again, we're going to temporarily, we have an x cubed on top, and we'll have an x to the k on the bottom. Do some mental math and see if you can figure out a k that all your x's would cancel out. Because you need all your x's to cancel out. Has someone found a k that doesn't work? 12? Yeah, 12 would give you 0 on the top, right? And 12 on the bottom. And sometimes that's the best strategy, is to start with a couple. Like if you can't find one that works, start with a couple, and then you start to figure out, oh, I need a bigger value of k or a smaller value of k. And you can also solve it algebraically. I was going to show you that next. But if I find that it doesn't take too long to plug in some values of k and figure it out. Has anyone figured out what the value of k works? Does 9 work? because then you'll get x to the 9 on the top and x to the 9 on the bottom. All the x's would cancel out. Okay? You can also solve this algebraically because you just have to use your exponent laws. So algebraically, what does this look like? This is going to be 36 minus 3k on the top over x to the k on the bottom. What is your exponent law for dividing? Subtract, right? So now this is x to the 0 on this side, and on this side you'd have 36 minus 3k, and then you'd subtract another k. What did we do in our exponents and logs unit when we're solving for an exponent and our bases were the same? Once you get to this point, these two have to equal, right? So 0 has to equal 36 minus 4k. 4k has to equal 36, divide by 4. And you get k is equal to 9. So that's an algebraic way of solving for k, and that's fine to do that. Although I do find it doesn't take very long to plug in some values and figure it out and get k equals to 9 that way as well. Yes? The previous one we could have solved algebraically as well.
Are there ones where you can't?
No, they can all, if you want to do your exponent laws,
Are they all that simple?
for the most part, yeah. Now we're finding a constant term, and what's going to happen on a test is if I ask you the constant term, you're going to put your hand up and you're going to say, what does this mean? And I'm going to say, we learned that in class. Make sure you remember what constant term is. That's no x's, and then I'll tell you if you can't remember the definition, then do the complete expansion, and maybe one of the terms will jump out. And guaranteed that's going to happen on the test. Someone's going to ask that question, and I'm going to have to, happens every year.
So when instead of 5x cubed minus 2 over x, and it just would be like 5x cubed minus 1 or so, then the last term is a constant term.
Yeah, then the last one would be a constant term if there's no x's in that. Okay, so now that we've found that k is 9, we still have to find the constant term because the question didn't ask which term is the constant term. We know that it's term 10, so we'll have 12, choose 9. Our a value, what was it again? 5x cubed. 5x cubed to the 3, 12 minus 9. And negative 2 over x to the 9. Calculate each of these separately. Twelve choose 9 is 220. 5 cubed is 125, x to the 9. And negative 2 to the power 9 is negative 512 over x to the 9. Multiply our numbers together. Negative. There it is. And the x's will cancel out, so there's our constant term. It is quite possible to get some very big numbers in this unit. And from the homework, you can do question number 9.